How do you solve the given exponential equation here? As you can see, the x that you're going to solve for is in the exponent, right? So you have to somehow solve for x. And this picture may look really ugly to you, and most of the time students really hate these kinds of problems, but I will show you how to do this, and you will be able to feel at ease with these kinds of problems. So first of all, notice that the laws of exponents allow us to actually rewrite the first term as 3 to the 4th being separate raised to the square root of x power, right? Because we know the power of power is such that when you have a power inside and the power outside, the powers simply multiply, right? And this is what the original shows. The two powers essentially multiply, so you can separate them and assign 4 as an exponent of 3 in parentheses and then raise that to the square root of x, right? And why am I doing that? You're going to see the reason why. So we're going to copy the rest. 5 times 9 to the square root of x is equal to 126. Now the next thing you want to do, you want to write the first term as it should be, right? The first term number, 3 to the 4th, is actually 81, right? So you know this is equal to 81 to the square root of x plus 5 times 9 to the square root of x is equal to 126. Okay, so that should be clear. 3 to the 4th is 81. Now, the next thing you want to do, as you can see, the fella that you're looking for is this fella, 9 to the square root of x, right? That's the magic number that we're going to use. And it's a very important number, 9 to the square root of x. So we can split up the 81 in terms of 9 times 9, right? Because we're looking for the 9 as the base number, not 81. So what we're going to do now, we're going to transform this into a 9 times 9 raised to the square root of x plus 5 times 9 to the square root of x. And then let's subtract 126 from both sides because it's going to be easier that way. It's going to look like a standard form equation, or at least something like that, right? When it's set to 0. So all I did now, I just subtracted 126 on both sides, and that's how I wound up with the current equation. So now, as you can see, 9 times 9 raised to the square root of x, again, another law of exponents allows us to actually assign the exponent of square root of x to each of the bases, right? So 9 square root of x times 9 square root of x, right? This is how this splits into this, right? Using the laws of exponents. Now, plus 5 times 9 square root of x minus 126 is equal to 0. Now you may probably notice something. So notice that both the first and the second term, 5 and the 9 raised to the square root of x, multiply 9 square root of x, right? So what I'm getting at is that both 5 and this multiply 9 raised to the square root of x, right? And this is very important because that's going to help us actually transform this to the quadratic form equation. You might ask, well, how do you do that? That doesn't look like a quadratic. Well, here comes the substitution. The substitution will let us do that. So what you're going to do next, you're going to let y be equal to 9 to the square root of x power. And that means, as a result, this will be the product of two y's, right? Because each y represents 9 to the square root of x. So that means the first term is going to be y squared, right? Y times y. Y squared plus 5 times y, because this represents y. I'm going to circle this substitution, right? So 5y, right? Minus 126 is 0. Don't you think this is much easier than that? That means we can actually factor the left side of this equation. And the factors might not come to you right away because of this huge number 126, right? You might think of what are the factors of 126 that negative 126 that add up to positive 5. Well, it's going to be y plus 14 and negative 9, right? So y plus 14 and y minus 9 are the factors respectable to the left side that we just used. So that's set to 0, so that means y plus 14 is equal to 0, or y minus 9 is equal to 0. So in the first case, you subtract 14 on both sides, And what you're going to get is y is equal to negative 14. In the second case, when you add 9 to both sides, you will have y is equal to 9. Now you might say, where do we go from here? Well, we have to go backwards in the substitution. Remember that y was set to be equal to 9 raised to the power of square root of x. So that means we substitute backwards, right? So that means the first one means 9 to the square root of x is set to negative 14. And in the second case, 9 to the square root of x is equal to 9. Now notice something here. First of all, x should be 0 or positive, right? Because the square root, since it's a square root of root 2, that is, all even roots do not allow you negatives inside, right? So x can only be 0 or positive. Now, if it's 0, 9 to the 0 is going to be 1, right? Not negative 14. If x is positive, there's no way that this exponent will be negative, right? Because we can't have a negative inside, right? We can only have a positive. Since it's an even root, it's a square root, right? So that means this can be only 0 or positive. In either case, 0 or positive exponent for the 9 will never give you a negative number, right? So we must cross this out because this is not a valid choice that we should use, right? This produces no real solution, right? No real solution. And again, why? Because there's no value of x that will ever give us a negative number. Okay? Now, in the second case, since the bases are the same, that both bases are 9, that means the square root of x can be set to 1. And why is it 1? Because there's a secret exponent to the 9, which is 1, right? 9 to the first power is 9, right? So essentially what we're doing, we're assigning these square roots, we're assigning these exponents equal, right? Because the bases are both 9. So that means square root of x is equal to 1. Now if you square both sides, you're essentially squaring both sides. So that means x will be solved for, right? And that becomes 1. 1 squared is 1. Now, before we say this is a solution, we have to check. We have to check this alleged solution in the original equation, right? Given on the top. So let's do that. So checking, first we're going to check the left side. 3 raised to the 4 square root of 1, right? Because we're substituting the square root of x with square root of 1, right? Because we found the value of x. Now plus 5 times 9 raised to the square root of 1, right? For the x is equal to 1, is equal to, now let's see if this whole thing is equal to 126. If it does, that means the solution checks. It is a solution. So square root of 1 is 1, so that means 4 times 1, the exponent, plus 5 times 9, square root of 1 is 1. So let's see what that gives us. 3 to the 4th plus 5 times 9. That gives us 3 to the 4th. Originally we knew that was 9 times 9, which is the same as 81, right? So 81 plus 9 times 5 is 45. So 81 plus 45, that's 121 plus 5, 126. Bingo, right? So that checks. So that means this is a real solution. This is the only solution that checks. X is equal to 1, right? So x is equal to 1 is your solution. So as you can see, this is not too bad. These kinds of questions are not too bad. Watch my 2 other videos because I will give you a harder question, and especially the third video with a very with the crazy exponential expressions there. You're gonna love that video. It's a very difficult question to solve. Okay, so thanks for watching and see you in those videos.